I think the last session of today, it's session 4R, and Tony Antler from BMC is going to talk about platform engineering and why should I care. And everybody who joins is on mute by default, and their video is switched off by default. That's just to be respectful to the presenters and make sure that we don't hear unnecessary background noise or see things that we don't want to. Everybody can access the chat, so post into the chat. If you want to, Tony's going to take questions towards the end, and towards the end, if there's an extra 5 or 10 minutes, and anybody wants to be unmuted, just ask in the chat. Both Tony and myself. So I'm Joe Winchester. I'm the sort of moderator for this. We've got superpowers, so we can unmute you all. Cool. Go for it, Tony.
Thank you, Joe. Thank you very much, and thanks everybody for attending this session. Everyone is talking about platform engineering. Why should I care? My name's Tony Anter, Anthony Anter. My friends call me Tony, and since you're here, I'm assuming we're all friends. So we'll go ahead and everybody use Tony if you address me. I wanted to put together some discussion around platform engineering and what I see as platform engineering and how I think it affects us in DevOps in general and on the mainframe. But first, let me take a moment just to chat about myself. So if anyone hasn't heard me speak before or doesn't know me, I'm from 2014 to 2021, I was a director of engineering for CI/CD at American Express. And I had the responsibility for and ownership of all of the DevOps tooling, all of the DevOps platform for both the distributed side, which is where I come from, and then eventually on the mainframe side. So all of the build, deploy, test, scan, security scan capabilities were either owned by me or integrated by myself and my team. This included all platforms. So this was distributed, cloud, mobile, mainframe, Salesforce, all of it. My team ran the platform for all of those. As such, about halfway through my tenure there, as we had more and more teams coming in, more and more people demanding services, the ability to service them and onboard new teams, new people, new applications, new everything became quite a bit of a burden for my team and became a bit of a burden for everyone in general. And we had the classic, put in a ticket and tell us what you want, and then that ticket will get assigned to somebody, and then that somebody will onboard you across N number of tools. Think about that from a net new point of view, right? I'm a brand new application with a brand new team, and I need to get access to all of my build tooling, all of my agile tooling, like things like Jira and Confluence and all that, which fell under this purview. I needed to get repositories created. I needed, SonarQube projects created, et cetera, et cetera, et cetera. All that was handled by a ticket. And like I said, that was becoming unwieldy. So what we did was we designed and created an internal developer portal, which basically allowed teams to come on and self-serve. So that there, if I had an application, I could get on, I could fill out the form, all of my information that I needed. And basically when I hit submit, behind the scenes, the platform would go out and use the APIs exposed by all the different tools to spin up and create everything that application team and that application owner needed in order to get started. And a process that took a week or two at best now took maybe an hour, maybe 2 hours at the outset, unless there was some kind of issue. So we were able to create a self-service onboarding platform that allowed us to now get out of the ticket business. And now tickets were only there for exception cases and for issues. And that freed up a lot of time and bandwidth for my team to not have to handle that onboarding. This was all before, I would say, people were really talking about platform engineering or the concept of platform engineering. But let's take a quick step back, just so that everybody gets on the same page and we're talking about the same thing. Now, I'm hoping that I don't have to spend a lot of time on this slide, or that there's a lot of questions, right? But what is DevOps? Because all this started, in my opinion, with DevOps. Now, I'm going to say in my opinion a lot, because there's a lot of different definitions and things around this. But if you look up, excuse me, if you look up DevOps on Google, the official definition per Google is a combination of cultural philosophies, practices, and tools that increase an organization's ability to deliver applications and services at high velocity. I think that's a pretty straightforward definition of what DevOps is, and I think it's pretty much everything that we would grow to expect that a DevOps offering would have. Some of the highlights of DevOps is continuous integration and continuous delivery, right? That constant feedback, the infinity loop. Collaboration, right? DevOps allows collaboration and the delivery and automation of software. Automation of the software delivery lifecycle. Development tool. I think DevOps also is as much about developer experience or builds into the developer experience realm as much as it does automation and CI and CD. And of course, I think DevOps doesn't stop with dev. It also includes the handoff to operations and monitoring and observability, right? And I think all of us on this call, I think everybody everywhere is either has a mature DevOps offering, is in the midst of trying to increase the maturity of their DevOps offering or doing something with it, or planning a DevOps offering of some kind, even on the mainframe. So I think this automation and this tooling, I think everybody's pretty familiar with DevOps. And I think DevOps answered a lot of questions, but it didn't answer everything. Like I described in my previous slide, now that I have DevOps and now that I have these capabilities, how do I make it easy for people to use? How do I make a platform that is easy for people to use and onboard? And my team don't become a bottleneck in how to onboard to this platform and how to use it. So what is platform engineering? So I've talked about DevOps. Now what is platform engineering? Per Google again, platform engineering is a process of designing, building, and maintaining workflows and tools for software engineering organizations to drive consistency and speed up common tasks. Now, if you go and you do your own Google search, you're going to find about 20 definitions of what platform engineering is, right? You're going to find different people have different perspectives on platform engineering. I think that this is a generic enough definition that it could pretty much mean anything to anybody. But my opinion is and has always been that DevOps is the next platform engineering is the next natural progression of DevOps. You have to have a DevOps offering and a solid DevOps offering, but then from there, you will eventually get to platform engineering, right? It's a self-service and easy on-ramp to start using your DevOps. The point of platform engineering is to make things self-service so that your application teams do not have to engage somebody in order to be able to use the tooling or in order to be able to do their job, to onboard and start creating great applications. It needs to be self-service and it needs to be very easy and intuitive. Platform engineering automates the automation, right? Again, easy access. It needs to be an automation capability that brings people automation for their DevOps pipelines and tool chains, right? Platform engineering needs to be easy and automatic. Just like when we created that portal at American Express, we made the onboarding and the process of it very easy. It enhances standardization and compliance. Giving people self-service capabilities doesn't mean that you need to create the Wild West. It doesn't mean that you create everybody has root access to everything and can just do whatever they want, because that will end up in a disaster. You will have people stomping on each other. You will have people messing each other up, whether by hook or crook, whether by accident or on purpose. You'll have people removing things and enhancing things and whatever without that knowledge across how the entire system works. By putting a platform engineering offering in place, you're standardizing what everybody does and how everybody works within a set of boundaries that give them the flexibility to do what they need. And it also makes sure that your offering, your DevOps offering and your automation is compliant. You build that compliance, that change management, all of those, security strictures for those that are in audited, regulated and audited industries. It makes sure that compliance is built in. So now there is no opting out or going around. Everything is built in. So you standardize and you make it compliant. Platform engineering is a complement to your DevOps offering. It is not a replacement for your DevOps offering. It is not in lieu of your DevOps offering. It is not something that is there to get rid of your DevOps offering. Platform engineering is an enhancement to your DevOps offering that, as it says here, complements and overlaps. Right? This also now makes your DevOps and SRE offering, which I've always considered SRE the ops side of DevOps, the automation of operations. It makes them a singular offering, right? It puts them onto a singular platform that now everybody can use and everybody can use and everybody can make use of, right? So you have DevOps and you have SRE. And if you look, though, of course, those complement each other, right? DevOps, in my mind, has always been the automation of your application development, your SDLC. The ops side of DevOps is SRE, the automation and of the ops process. But platform engineering encompasses both of those. Platform engineering encompasses both of those and complements them, and make sure that each and every application team or operations team that wants to make use has a platform and an easy onboarding ability to get onto these platforms. Like I said, platform engineering is the next natural progression for your organization. And if you're not already practicing it and you have a centralized team that is doing DevOps or SRE, then this needs to be the next thing that you start to look at. And it encompasses both. So what are the 4 keys to a platform engineering offering? And when I thought back on us when I say us, when I was at American Express and we created the platform, I thought back on what we did and how we created that platform to automate all this. And I thought back to what were those keys that we used for creating it, and these are the keys that I came up with, these 4. So first, you need to make your platform a product offering. Your DevOps platform, your SRE platform, and by extension, your platform engineering platform. You need to make this into a product offering. It should have a product manager or a product owner, a backlog, and a roadmap. the same as every other application in your organization. Now, is it customer facing? Is it being rolled out to your end user customers outside your organization? No. But if you do DevOps right, and you do DevOps and SRE and all those capabilities correct, then your customers are your internal application teams. And just because they're internal doesn't make them any less a customer than before. So you need to have a product manager who applies product management practices to your platform and make sure that your capabilities are meeting your customers' needs. Like I said, your customers are the internal engineers for your platform services. So you need to treat these internal teams the same way that your organization treats customer-facing capabilities that you roll out to the general public. As this is a product and you have a product manager and you have internal customers, you need advertising and marketing. You need to be able to proselytize the fact that you have this platform and that you've added all these capabilities. Excuse me. You've added all of these capabilities to your infrastructure in order for them to buy in. You don't want to create your platform in a vacuum of silence and no one knows that it's there. You need to advertise and you need to market the fact that you have this. And now this is your way to get the products and services that you're offering via DevOps or SRE. Basically, build it and they will come does not work. For anyone who's seen the movie Field of Dreams, that's a line from that. Like, they keep telling the guy, build it and they will come. Right? So he builds a baseball diamond, it's cornfield. And yeah, I'll let you watch the rest of the movie in case anybody hasn't seen it. But that doesn't work in this instance. That doesn't work when it comes to DevOps and SRE, and it doesn't work when it comes to platform engineering. You have to have that advertising and marketing. And the main focus of this is reducing toil and cognitive load on your engineers. At the end of the day, like any other product, you're trying to give something to your customer that they want and need. And what they want and need is to make their day-to-day life better. Make the engineer focus on creating great applications versus worrying about how am I going to do this and how am I going to do that and what internal ticket do I need to put in and what TPS report do I need to fill out, yada, yada, yada. Reducing toil and cognitive load should absolutely be the primary scope and focus of making this platform engineering offering your product. Key number 2 is listen to your customers. In the previous slide, I established that your customers are the internal engineers for your platform services or your applications, right? So when you listen to your customers, do not create your platform in a vacuum. My mother always said that I was I was brilliant. I was smart. Okay. But as smart as I am, I can't sit here and define what an offering like this should be for the entire company. Right? You cannot create your platform in a vacuum of just your thoughts. You need to do research and understand the process and pain points that your application teams are going through, right? You have to do your homework. You have to sit down and map out all of the different applications. And that doesn't mean you have to map out every single tiny application in your whole organization, because, well, with like a company like American Express, that would have been impossible, right? But you at least need to do the research to see where are the main pain points, where are the main process hiccups that you have. You need to partner with those lighthouse teams and make them a part of the design. Excuse me. So a lighthouse team are those teams that are willing to jump into things like this first, your pilot teams. As I was doing the research for this and I was looking around, I ran across this term of a lighthouse team, and I thought it was actually very good. It's that singular team that sort of guides the way for everybody else. And you know they're out there. You know those teams that are passionate explorers and are looking to improve. And I think this is especially important on the mainframe because a lot of this is ground that mainframe applications have not really trod before. So partner with those teams and make them a part of the design. Fold them into what you're doing and let them inject requirements and scope into what you're going to be doing with your platform engineering offering, right? And this will never be done. You're going to need to continue listening to feedback and requirements. Just like any application, you're going to develop this and you're going to talk through, you're going to listen and you're going to put an initial MVP offering, but then you're going to continue to listen to feedback and requirements. As you expand the scope of what your platform engineering offering does, you're going to have to get more and more and more feedback, and you're going to have to keep exploring. And you'll probably have more than one lighthouse team. You'll probably have multiple lighthouse teams, especially if you span many platforms like what we did. And the 80-20 rule is a rule to live by. No matter how much you listen, no matter how much research you do, no matter how many partners you have, you're not going to be able to create a platform that's all thanks to everyone. That's impossible. So you want to follow the 80-20 rule where possible. If you can deliver 80% value, the 20% will work itself out. But you have to keep calculating that value to work ratio to see where you're going to provide the most value. Where are you going to provide the most capability? Looks like we have a couple of questions. I was going to wait to the end. Oh, there we go. Looks like Joe already answered that one. So, sorry, I should if I had known, I would have spent a little bit more time on SRE, but as it is, I'm focusing more on the DevOps side of the platform engineering thing. So the 80-20 rule is a rule to live by. Oops. Key number 3. Set up a paved road, right? Set up a paved road. What do I mean by a paved road? A paved road is your easy way to onboard and get your application through the system to production, right? That's the concept of a paved road, right? Templates are your friend. You want to set up a set of templates that have all the capabilities and offerings that people want, but also give you the ability, give application teams the ability to adjust specific to their needs, right? You want to allow an automated path to production without needing to concern yourself with the underlying details. I should have a template that allows me to pull it down, add in my application specifics, and then provides me that paved road, that highway to get to production. And I'm not worried about the compliance issues, or I'm not worried about all those underlying details that my application team doesn't need to focus on. The template works and it pushes things down the path as needed, and it handles all the details. So now my application team can only needs to worry about creating a great application. And that's the purpose of this. You want templates, but you need to allow room for flexibility and innovation, right? You need to allow teams some flexibility within the guardrails on that paved road, right? You want to give them the ability to make some adjustments and some changes. And as long as they're not really affecting the standard nature or compliance, then within the bounds of that, let them go crazy. Let them innovate and create new capabilities. And at some point, someone might create something really cool that you then blend into the template and as part of your platform engineering offering. This is important when we're talking about this. The paved road is not the only path. It's just the best path. So I can tell you, I always say this, when we were doing DevOps and when we eventually created the platform and all that, we probably managed dev to production for 90+% of the applications in American Express. And why do I say 90+% versus 100%? There were some applications who didn't want to use our offering, right? They didn't want what we were doing. At some, again, when we started out, it was maybe 70%, and then we went to 80%, and then we went to 90+%. But over time, we started folding more and more of these applications in. And why didn't they want to use our offering? Some teams thought they were way smarter and better than us, so they could do it on their own. They didn't need us. They didn't want us controlling their infrastructure tooling or their infrastructure, and they wanted to do it on their own. They thought they were better looking than us. They thought they were cooler than us, whatever that may be, right? Some teams had a legitimate reason and a legitimate technical issue as to why they couldn't use our pipelines. And again, going back to the 80-20 rule, we weren't able to fold them in as part of the MVP, right? So the paved road needs to be the paved road. It's not the only path. If somebody wants to cut their way through the jungle and blaze a trail over the mountains and through the woods and, across the rivers, then okay. My job at American Express was not to kick in doors and pull Mac Minis out from under people's desks. It was to create a really good offering. And if someone wants to go their own way, then let them go their own way. There might be legit reasons even, but they need to follow the same strictures that you do for getting from dev to production. And the paved road is there to make it all easy. So at some point, if you do this right, it's the natural way people are going to come, right? If you make it flexible enough and you make it easy for people to get what their work done, then they will naturally come. Focus on reducing toil and cognitive load. If you think that's a mistake in the PowerPoint template and I just forgot because I reused lists, you're wrong. Just like when we're talking about making this a product offering, when we're talking about setting up a paved road, the whole point of this paved road is to reduce toil and cognitive load. It's to make it easy for your developers and your development teams to go through and to have a quick path, not a quick path, but a safe and easy path to production, right? Sometimes quick means we're just popping stuff into production, and that's not the case at all. So key number 4, measure, 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 right? The 4th key to having a really good platform engineering offering is in the measurement. It's in the KPIs, right? You definitely want to measure adoption. This is going to cost you time and or money. If you build it on your own, which is what we did, it's going to cost you money in the form of time and resources that it takes to build it and then to manage it. If you get an off-the-shelf product, then there are some out there. There are some platform engineering offerings that companies have. Then it's going to cost you green dollars. Either way, well, I guess green, depending on what country you're in. I forgot this is an international conference, so it could be green, it could be whatever color the pound is, I'm not sure. So, but anyway, you want to measure adoption. You want to see how many people are onboarding and how many people are using your platform engineering offering. And if you're not doing that, or they're not adopting, then what did you do wrong? What capabilities are lacking that people don't want to do this? This is the same thing that any product manager is going to do when you have an offering that they roll out to the public. You want to measure developer efficiency, right? If you're going to make this offering, you want to be able to measure developer efficiency, both in their DevOps pipelines as well as through the paved road. So you need the ability and KPIs like the Door 4 metrics that measure developer efficiency and how well things are running. You want to measure customer satisfaction. That can be in the form of surveys, that can be in the form of town halls, that can be in the form of anything that you want. But you want to get those customer satisfaction metrics to see. And again, just like the adoption metrics, that gives you an idea of, have I invested my time in the right areas? Have I put the correct scope and capabilities into my platform that I need to, right? Quality, velocity, and efficiency. You want to measure how easy it is for me to get a load from dev all the way through to production. Just like any paved road, there could be some potholes, there could be some inefficient turns, there could be some lanes merging together that are causing slowdown. So you want to be able to measure that velocity and efficiency of using your paved road, and then also make sure that anything that people are using your platform that they're pushing into production, that your quality is staying the same or improving, right? And the last thing you want is you want to measure return on investment. Like I said, this is going to cost you money in one form or another. So you want, using the 4 metrics above, to put some kind of return on investment calculation together so that when your manager goes, okay, you asked me for 4 months to build this and put an MVP out, how are we doing? You want to be able to show them that you have an ROI both for the platform that you created, as well as an ROI or return on investment for what you, for a return on investment that for your application teams that are pushing things from dev to production. And using a platform engineering offering is actually a really good way to consolidate all that. It's a really good way to show, not just for the platform, but for your DevOps offering in general, what are some of the KPIs and metrics for this? So when you do this and you build it out, you want to build this ability to measure KPIs in from the very beginning. So when I bring this up, what I hear a lot is, but I'm on a mainframe. I'm different. Mainframe's different. You don't understand. Mainframe is it's a different animal. It's a different place. It's a different thing. So what? My answer to that is so what, right? You're on a mainframe. The mainframe, and this is a mantra that I know BMC has touted, IBM has touted, Broadcom has touted, everybody is touting this same mantra. The mainframe is just another server in your data center. We need to get out of this idea that the mainframe is some special unicorn dancing through the fields that requires all these special capabilities. Are there nuances to the platform? Sure. There are nuances to the cloud platform. There are nuances to traditional VMs. There are nuances to publishing a mobile application. But these are all just capabilities, platforms that can be added in to your paved road and added into what you're automating, right? You're already practicing DevOps. I would argue that everybody on this call, everybody attending GSE, everybody, almost every mainframe shop I have talked to is either practicing DevOps or talking about practicing DevOps in some form or fashion. So this is just an extension of that. Automating your team's ability to do things isn't a bad thing, no matter what the underlying platform is. And the platform and platform engineering should be platform agnostic. I know I use the word platform in like 8 tenses there, but platform engineering should be platform agnostic. It should not matter whether I'm an application team that's ultimately going to deploy my capabilities onto the mainframe or onto Azure or AWS or Google. It shouldn't matter, right? My ability to onboard and get access to a pipeline and tools that I need shouldn't change. The only thing that changes is the underlying implementation tasks that are needed inside that pipeline. And again, the whole point of this is to divorce yourself from that. So the platform engineering should be agnostic. You should strive for everyone to be on the same development platform, regardless of whether they're writing COBOL to deploy to an LPAR on your mainframe, or they're writing Go to create an image to deploy on AWS. The actual development platform should be exactly the same. Everything else is an implementation detail that really doesn't need to be considered. That's table stakes. So how do you get started, right? Hopefully this has tickled someone's fancy on the call, and everybody's itching to get started on building out your own platform engineering offering. So how do I get started? So the first thing is you need to sit down and build it, right? I think all of us in this industry and business have been involved with scope creep, have been involved with projects that go on and on and on, and what a death by implementation detail. You plan and you plan and you plan and you look for that perfect moment and that perfect scope and that perfect thing. You just need to sit down and build it. Start with a platform, start with an easy use case. I want to onboard to my Jenkins offering. I want to onboard to Azure DevOps. How do I do that? And start with that and create a simplistic use case and build it from there, right? So you can build it or you can buy it, right? You can go out and find an off-the-shelf offering that automates all of this and makes it easy to install and get started. So let's look at both of these scenarios and let's see some advantages and disadvantages. Right? So if you build it, right? If you take my advice and you build your application, or excuse me, you build your platform engineering offering, you can customize it to whatever you want, right? You don't have to worry about a vendor lock-in. You don't have to worry about, I bought this from XYZ vendor, so now I have to use all their tools and all their capabilities and all their things. And most vendors today make their stuff vendor agnostic. But if you build it yourself, then it's truly agnostic, right? You can build the pieces you want, how you want, and then create them in a way that they're plug and play. So I can disconnect a vendor if I want, and I can bring a new vendor in. And there's lots of open source options that are available to you. There are lots of platforms and platform capabilities that are out there in open source that you can build and that people have been customizing for years and years and years. So there's lots of options you have. Two cons though, just like anything, there is no right or wrong answer, right? The con to that is, first off, I know, and Joe is probably going to unmute himself and start yelling at me, but free open source is not free, right? There is no such thing as free open source. You might not pay a license fee for it, but you are also on the hook for the management and support of it. So the idea that free open source is free is not. It's like the old, for anyone who took economics when they were in college, right? That what's that? There's no such thing as a free lunch. Well, there's no such thing as a free software package either, right? Just like your lunch. So you can go open source, and I love open source. I think open source stuff is great. I think it should be your first inclination for everything. But just to understand it, it's not free. And along those lines, you build it, you own it. There's no support. There's no neck to choke except for your neck, right? If you see any bruises on my neck, that probably comes from the platform I created at Amex. So you build it, you own it. So the con is no support. Now, does that make building it right? No. Does that make building it wrong? No. It really depends on what you're trying to achieve and how you're trying to achieve it, right? You can buy it, right? You can buy your platform. The pro is you can set up, configure, and go, right? All you're really doing is installing it and then spending some time configuring it, and then it's ready to go. You don't have to have a team of people and design it. It's, mock-ups and screenshots and all that kind of stuff, right? Most common tools when you buy one of these off-the-shelf platforms are natively supported. So you're not going to have an issue integrating Jenkins or integrating SonarQube or integrating your testing frameworks or integrating any of your common tools. And it comes with support. All these off-the-shelf tools have support, and they have a support apparatus that you can call or send a ticket to or whatever if you run into issues and concerns. The problem here, again, is the possibility of vendor lock-in, right? The possibility of vendor lock-in is there, and so it's something you need to be cognizant of. Some of these can be hard to customize, or the configuration of it to fit the needs for your organization can be just as rigorous as if you built it yourself, right? So hard to customize, and or they maybe didn't think through all the scope and the requirements for your organization, so you can't necessarily customize it to exactly what you want. And it's upfront dollars. So now I have to sign a contract, buy this software, send it through legal, and I have to have money in my budget to have it and support it, right? Just like I said for Build It. Is it right to buy it? No. Is it wrong to buy it? No. It really depends, again, just like I said, it depends on your organization, on what your requirements are, what kind of team you have, and what you can support. Either direction is fine, as long as it meets the needs of you and your customers and what you're trying to do. So this is my talk through platform engineering and what platform engineering is. And again, you can have a lot of different spins and a lot of different thoughts on platform engineering and what it entails for you and your organization. But what I'd like to do now is open it up for any questions that you may have. So who is this? Charles Gaskell. For questions at the end, platform engineering should be platform agnostic. Strong disagree on it. ZOS ISPF is an engineering platform, but one where the platform engineering solutions works best within that engineering platform. Okay. I'm not going to completely disagree with you. What I will say is, though, is you bring in more and more and more people that aren't as familiar with ISPF or aren't as familiar with the green screen in general. They're learning their capabilities on IDEs and on a different development capability that will work just as well on the mainframe, right? Go ahead. That's fine. Joe, can you unmute him?
Yeah, Tony. Yeah. Charles, you should be unmuted now. I think you have to select, you have a pop-up that will appear on your screen, and you have to accept that, and it will unmute you.
Yay, got there eventually. Yeah, I mean,
thank you for the, first off, let me say thank you for the question. So go ahead.
We're kind of we're the organization I work for. We're kind of in a very different position. You're talking in terms of building a platform engineering solution, whereas we've probably had a platform engineering solution in place for at least the last 25, 30 years. I mean, would you agree that ISPF is a platform engineering solution? I guess is the first question.
I don't know that I would completely agree with that. I'm not going to.
In what ways isn't it then?
I don't think it really has the ease of so I'm going to take it from a DevOps point of view with the understanding, like I said at the very beginning, there are a lot of different definitions of what you would call platform engineering. But my opinion, my personal viewpoint on it is it isn't. And I would say it's more of a development capability than it is an actual platform engineering. You're not really orchestrating or automating things through ISPF across the board, and there's no real self-service capability to onboard to it.
Yeah, well, but on what we do is we extend it so that I mean, as a software configuration management tool that we use to support the development lifecycle, we've got Endeavour, which is definitely an orchestration tool. And we then have we have in-house built stuff to manage the movement between different testing environments.
I
it
would say
seemed-
that maybe you've then taken ISPF and extended it and created a quote
But
unquote.
I think from my experience of different organisations I've seen, I mean, everybody does that, but it seems to be a better way of doing it rather than forcing everybody to use the same engineering platform solution, regardless of which platform you're actually going to be deploying on.
So I think there, Charles, will have to agree to disagree. I understand
Okay.
that you like ISPF, and I think that's great.
No, I like
think
ISP,
that-
I like ISPF if that's ultimately where your application is going to run. If I had an application that's running in the cloud, then AWS, then fine, develop it within that platform.
Right, but here's
so-
what I would say, Charles. So I would argue that you can develop it on any platform you want. And again, ISPF is it. Listen, if that's what you like to use for developing your application and that's what you're comfortable in, then I think absolutely you should meet it there. But I think that's a level down from what we're talking about with platform engineering. And I would also say that as most organizations, that at least the ones that I go out and talk to and see, they right now, as they're bringing in new resources and new people and new I'll call it a new generation of developers, they're not ISPF savvy. So I can take 6 months to train somebody on ISPF and how to use it, or I can give them VS Code that they come out of college and they know exactly what to do and how to do it. And it ends up, the workload ends up in the same place, the same way. I don't think you can tell the difference between
I think you're exaggerating in both directions as to how VS Code ready people out of college are and how long it takes to learn ISPF.
Okay, well, maybe I could be exaggerating. Like I said, I think we'll have to agree to disagree. I think there are a lot of holy war discussions that people have about what platforms to do. Here's what I'll say. I think if you're going to have a development offering, you should have consistency across your organization, whether it's distributed, cloud, mobile, mainframe, whatever. Right. And I'm not trying to say that someone who's using ISPF should be forced to use VS Code, but I also don't think someone who likes VS Code and can develop just as well in VS Code should be forced to use ISPF just because they're deploying the mainframe platform.
Okay, as you say, that's for something for us to agree to disagree on. I mean, and also it might depend on the size of the organization. I mean, typically we don't have developers that are developing across multiple platforms. So
Again, even if you don't have cross-functional capabilities, that shouldn't matter. Your development should be your development, right? If I'm writing COBOL, can you tell the difference if I wrote it in Eclipse or VS Code or ISPF or whatever?
I possibly could actually, because of the coding style. I mean, the thing is, if you're writing for something that is going to be deployed on ZOS, you have to have a knowledge of what ZOS looks like. It's another of the points that you made earlier is that you said that ZOS is just another server platform. And in one sense that's true, but in another sense, it's not true. Every platform has its own unique quirks, and
sure, those quirks can be handled by implementation details that don't necessarily. I don't
think they're just implementation details. I think that's mischaracterizing them.
Okay, well, you and I will have to agree to disagree, Charles. I really appreciate the question, and I love a lively debate. But I want to give some other people a chance to
Yeah.
weigh in on this. So are you team Charles or are you team Tony? I'll throw that out to the rest of the audience. So thank you very much, Charles. Great question. Any other questions?
It was a great discussion. It was good watching the kind of irresistible force and the immovable objects sort of go head to head.
Do you like chocolate or vanilla, Joe? Which
it was just
which
like
one's your favorite?
ISPF versus VS Code smackdown. Yeah, so I mean, one
Well,
thing.
and let me clarify one thing. I am absolutely not against ISPF. I just don't think it's a quote unquote platform engineering offering. I think it's a development tool personally.
Right.
I
So
think
one
you
thing
should
that's
plug into whatever, but not necessarily. I'm all about meeting people where they want to be, not forcing people into a pathway outside of consistency.
so one thing that's interesting, Tony, is I know there's a whole drive towards like, configuration as code. So the idea that and you see this a lot in the sort of Kubernetes worlds and things like that, in that everything about your deployment artifacts should be managed by a source code manager. Then it doesn't really matter how people edit that. They can use Vim or VS Code or whatever. They can knock themselves out, right? As long as they're just doing commits and you've got PRs and good discipline around that pipeline. And then just some automated pipeline can deploy that and provision it and roll it back and give you that agility. How does that, and for platform engineering, what's kind of leading the space in that? What's the kind of, what are the key things to think, okay, these are going to win the race? Because I know CI/CD, there's loads of players, but then Jenkins has tend to be out there. And I know, there's Argo as well that I need to learn a bit more about, but what are the things that you think people should research more about?
I think people should research more about the build it side of this, right? If we're talking about a platform engineering platform, where I see most people going is not so much into the pre-made platforms, but actually the open source world. I think this is a really good application of open source technology and open source capabilities that allows you to pretty easily, almost as easy as to buy it and set it up and configure it, almost as easy as that, basically be able to set that up and go. I don't have any particular recommendations on which ones you should or shouldn't use, what technologies you should or shouldn't use. I mean, if you're talking a buy it one, Argo, that's one. But you brought up an interesting point that I want to double click on, Joe, which is the configuration as code, infrastructure as code, those capabilities. A lot of those, if you go out and do research on platform engineering, you see a lot of people conflating, in my mind, and I'm saying conflating infrastructure as code or everything as code as quote unquote platform engineering. And I think that's only an aspect of it. I mean, the idea is that your entire application can be defined in a set of configurations and a set of capabilities that, to your point, is put in a source code manager and versioned. And then every time I need to do anything, I spin that up and basically provision that. And I would argue, and I'm sure Charles will unmute himself when I say this, I would argue that mainframe has been doing that for 30 years, right? Maybe not in the way that it's done today, but it's been doing that for the last 30 years. So I think, to me, that's a part of platform engineering. That's a part of what you do. And
when you say it's been doing it, you mean because it's got like Palm libs and system and everything? Okay, so you can basically
you look at a platform like Ansible, right? For doing things like infrastructure as code and provisioning. And that's a great platform. But I would argue that's not a platform engineering offering. That is a platform as code platform that allows you to spin those up. But it's not managing, to me, the other aspects of what I consider platform engineering, which is the ease of use, onboarding, that kind of thing. I don't know, maybe I conflated your question, Joe, but that's how I look at it.
It's an interesting one. And what do you think about containers coming to Z? So container, there was an announcement. It's just really, the paint's really wet. I think it was only a month ago or less than 2 months ago. And if you look at the distributed world, they're all about spinning up containers and having containers inherit from other containers and having this kind of topology around how you deploy and manage at scale. Do you think that's interesting for the ZOS platform, or is that just too late to the party, or?
I don't think it's too late to the party at all. I think it's incredibly interesting to the ZOS platform. And I think, to me, I can't wait. I think one of the missing pieces in DevOps for the mainframe has been that ability to quickly create those testing environments, just in the testing aspect alone. Quickly spin up and create a testing environment, immutable testing environment that I can run all my tests against, and then take it down, right? I don't need to constantly run the infrastructure, constantly run that continuous set of infrastructures and have 28 testing environments. If I could spin them up quickly and easily, I think that's going to open up a whole floodgate of automation. So I think the idea of containers on the mainframe, it's not too little, it's not too late. It's when can I have it? When can I have it, and when can I have it in a consistent way that isn't going to cost me an arm and a leg from a licensing point of view? The issues I see with it has more to do with licensing than it has to do with technology.
Cool. I think, Charles, you're unmuted now if you want to.
Yeah. So every time I mute myself, I then can't unmute myself afterwards. I mean, containers. I think being able to spin up containers and then destroy them, I think, is kind of less important on the mainframe side of things, because the mainframe was the original cloud. It's all about shared resources and shared stuff. There's less need to spin new stuff up temporarily, because it's there, it's available to be used, but on a shared basis between different developers and development teams.
I actually completely agree with Charles on the fact that
goodness gracious me, never
I
happened.
tell you what, Trey, you know what? What is it? A broken clock is right twice a day, right?
Yeah.
I think that you're 100% correct on the fact that the mainframe was the original cloud. All the concepts that you see in cloud computing have been on the mainframe for decades. That said, I think can you make a mainframe work in the way you're talking? Let me say that a different way. Mainframes work the way you're talking about, but now you're limiting yourself to the amount of infrastructure you have. I can only have N number of parallel paths going on at a time without stomping on each other, versus with a container, I can do anything I want. I can spin one up and I can do whatever I want in that container in complete isolation. Without having to worry about anybody else. And that's where I think the benefit comes from an R&D point of view and from a testing point of view.
But that only really applies to the unit testing phase of the SDLC, and unit testing.
I would argue against that, but primarily for you.
In terms of spinning up stuff that's purely for a single developer, and for the notions of not trampling over and trampling on top of each other, that tends to be a unit test problem rather than a system test, integration test type problem.
Yeah, no, I don't disagree with that, but ask yourself, how valuable would it be if I could, as an organization, make sure that I test these changes in isolation before they get integrated in with everything else, so that now I'm not having to worry about it. I'm not having to worry. It's less issues going down the pipe, and I'm discovering them quicker and sooner.
Yeah, but the whole idea about CI, continuous integration,
right,
is that you're not just that things don't get tested in isolation. I mean, you do isolated tests, but that you do them within an environment that's shared with other people, so that you not only find out whether your own code works, but you find out whether changes that other people have made to other pieces of code will impact on the code that you've changed.
Well, that's integration testing. To be frank, that's integration testing versus.
No, that's unit integration testing.
Okay.
There's two
No
different.
offense, Charles, I think
there's
that's a combination you made up on the fly there.
No,
Never really unit integration.
there's two different stages of. You're still testing the piece of code that you've changed. Just not in. You're only testing that bit. You're not testing the integration tests. Test out the integrated system. But there is also unit integration testing, which can take place much earlier.
That's a new one. That's a new one for me. So I'll do some research on it. And maybe at the live event, we can present something together on unit integration testing, Charles.
That was going to be my thing to Charles and Tony. The two of you, we need to get the two of you together in Whittleby Hall. It'll be a sellout.
Yeah, this will be like what is it, Khrushchev and like when Khrushchev and Eisenhower got in the room and started going at it.
Kasparov and Karpov or something like that.
As long as I'm Eisenhower, I'm okay. So
yeah, no, it is 5:30 now, and I want to be respectful of the time. Tony, thanks so much for that.
Absolutely.
I think do you have the final slide that has the URL for folks?
I have not. Oh yeah, sorry. Let me get
There's
that.
one. It's just the URL, and then it will have your session ID, which I think is 4R on the end.
Oh, sorry.
It's no big deal. If not, you can find it.
There we go. Nope. So the session is 4R, and you can see the QR code there. So please fill out. I love to hear feedback. Charles, just don't send me a bunch of poor feedback because you disagree with my topic. So outside of that, I thanks everybody for coming, and thank you for Charles. Absolutely, thank you for the questions. I love it. So hopefully I'll see everybody at the live event.
Yeah, thanks so much, Tony. And if anybody wants to, it's probably just kicked off a minute or two ago. So Mark Wilson's giving the closing keynote, Good, the Bad, and the Ugly, which should be a little bit of fun. And Mark's a great speaker as well. So if anybody wants to drop across to that, I can post the room number for that if anybody's interested, if you haven't already got it.
Thanks, everybody.
Yeah, thanks so much, Tony. Cheers.